Welcome back, coders. Today, we're diving into an explainer for Lesson ID STEM Python Unit-06, Lesson Pack 02 Setup Evidence Discussion Video Overview, exactly titled Setup Evidence Discussion Video Overview. For all of you Grade 7 programmers currently tackling Unit 6 on functions, we're about to learn how to read function setups like a real detective. We're going to treat our Python code like a scene where crucial evidence has been left behind, and it's entirely up to us to interpret what those clues actually mean.
Here is our quick roadmap for today. We'll start with the function misconception, move into discussing the evidence, walk through a worked example, give you a chance with your turn to transfer, and finally, wrap up with our final lesson takeaway. Let's get right into it.
First up, Section 1, the function misconception.
We're going to kick things off by tackling a massive stumbling block I see all the time when Grade 7 programmers first start working with functions. A lot of new coders, maybe even you at some point, just assume that when you call a function, you absolutely must pass every single argument in a fixed, rigid order with zero exceptions. Like, if a function has 4 parameters, you might think you have to manually type out 4 specific inputs every single time you use it, but is that actually true? Does Python really force you into this rigid box?
Well, no way. The reality is that Python functions are incredibly flexible. In fact, according to the official Python documentation, the most useful form of a function definition actually involves specifying a default value for one or more arguments. That means a function can literally be called with fewer arguments than it's defined to allow. You don't always need a rigid manual input for every single parameter. Python can actually just use those default argument values to fill in the blanks for you.
Moving right along to Section 2, discussing the evidence. Okay, so we're going to treat our code like a crime scene, actively looking for evidence. When you look at how a function is set up, you're essentially looking at clues that tell you exactly how you're allowed to call it, and every good investigation starts with the def keyword. As the Python docs state, the keyword def introduces a function definition. It absolutely must be followed by the function name and a parenthesized list of formal parameters. Think of this keyword as your ultimate piece of evidence. It tells Python a new function definition is being set up, and it associates that specific function name with the function object in Python's internal memory, its symbol table.
So the really crucial point here is that by just glancing at that setup line, literally just the very first line of the function, we can gather some major evidence about how it's going to run. We get the function name, we find out exactly which parameters are mandatory and require positional arguments, and we discover which parameters have those handy default argument values already assigned to them.
Let's investigate a specific setup, pulled straight from the official Python documentation. Here, we've got a function named parrot. Now look inside those parentheses. Those are our parameters. We have a mandatory voltage parameter. And notice there's no equal sign next to it, which means it requires a value from us. But then we have a state parameter, and this one does have an equal sign, followed by the string a stiff. That string right there is our default argument value. The evidence is screaming at us. If we don't provide a state, Python is just going to use a stiff.
All right, on to Section 3, a worked example. Let's see how all this builds when we actually call the function we just investigated. Let's trace the execution. If we write the call parrot 1000, we're passing in a single positional argument. The first piece of evidence we provide, the number 1000, goes directly into that required voltage parameter, because remember, they're evaluated in order. And what about state? Well, because we didn't provide a second value in our function call, state just leans back and relies on its default value, the string a stiff. The function doesn't crash, it just uses its built-in backup plan.
Tracing the flow of our data like this shows exactly how the setup evidence dictates the function's behavior. The voltage parameter gets our passed value of 1000. The state parameter gets the default passed value of a stiff. It's just a clean, super efficient way to handle function calls without forcing you to write out every single detail if the default works perfectly fine.
Okay, let's jump into Section 4, your turn to transfer. I've been playing lead detective here, laying out the investigative process, but now it's your turn to transfer these skills to a brand new case. It's time to test your detective skills on a slightly different setup. Here's a new piece of evidence, also straight from the Python docs. We have a function definition starting with def cheese shop. Then we open our parentheses and see 2 items, kind, followed by a comma, and then star arguments. Notice anything interesting? That second parameter features a special star, an asterisk, right next to it.
So based on what we just learned about reading the setup line, what does this specific structure actually tell you about how you must pass data into it? Take a really close look at kind, and then look at star arguments. Think about what the official Python documentation might say about handling a variable number of arguments.
Well, the evidence clearly shows that you absolutely must provide the kind argument first. It's just a normal, everyday positional parameter. But that little star next to arguments, that means it specifies an arbitrary argument list. According to the Python docs, these variadic arguments literally act like a net. They will scoop up all remaining input arguments that get passed to the function and wrap them all safely up into a tuple. So you could pass 1, 2, or 20 extra items, and they all get scooped up by that single parameter. Pretty cool, right?
And finally, Section 5, our final lesson takeaway.
Let's wrap up our investigation today with a final thought to lock in what we've learned about reading the evidence in a function definition. If you ever find yourself confused about what a function actually needs, just remember, go right back to the source. The setup line, the one starting with that def keyword, has absolutely all the evidence you need. It tells you the mandatory arguments, it reveals those handy default values, and it shows you if there are special parameters ready to scoop up extra data. It is literally your ultimate blueprint.
Python is just full of incredible tools, and reading compound statements like function definitions is your master key to unlocking them. Keep investigating those parameters, have fun coding your Python functions, always look closely at the evidence left in the code, and I will see you in the next explainer.